So I will do this example. Okay. Uh, so so you can see that so we are given a signal. Okay. So we are given a signal that is xn. Okay, that is xn is equal to n a n cos omega naught n u n. Okay. So this is the signal. Okay. So if you're going to if you if you try to do this using the Z transform, the basic Z transform, using the basic Z transform method, so it will be n minus infinity to plus infinity xn z minus n. Okay, so if you go through this method, okay, so you can identify that here it is this signal is multiplied by un. Okay, so this signal will become a partial signal. Okay, only plus sided values are there. Okay, so this will be n 0 to plus infinity. Okay, now xn is this n a n cos omega naught n. Okay, cos omega naught n. Okay, so and it will be z minus n. Okay, so if we try to expand this, okay, so we will have, so n is equal to 0. That means here 0, this one 0, this one 0. Okay, so because of this 0, okay, all these terms will be 0. So you will have 0 here. Plus, when the n is 1, okay, so you will have 1 here, a1 cos omega naught 1. Okay, and z minus 1. In the same manner, if the n is 2, you will have 2 a2, okay, cos omega naught uh, 2, okay, cos omega naught 2 z minus 2 plus 3 a3 cos omega naught 3 z minus 3. So okay, so you will get this kind of series. Okay, but the problem is that okay, actually problem is with this term. Can you remember? Can you guess? Can you identify it? The problem is with this term. Okay, if we don't have this term, okay, so so we will have a fine nice series. Okay, uh, 0 1 a1 is at minus 1, 2 a2 is at minus 2, 3 a3 is at minus 3. Okay, so sometime maybe it is possible to get the help from Taylor, no? Okay, from the Taylor or Maclaurin, no? Okay, so maybe sometime these guys may have a solution to find that kind of to 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 get the idea of that kind of series. I'm not sure. Maybe we have. Okay, but you can see that if this terms is available, so you will have different value here. So this value will be different. This value will be different. This value will be different. So the coefficients will be different. There is no any. So we can find the using the deep mathematical things. Okay, sometime we may able to find a solution. Okay, but it is somewhat difficult. Okay, okay. So this approach is not preferable, no, because we have a power series. Okay, so analyzing this power series sometime may be more difficult than to analyze this signal. Okay, okay, so if we have a compact form, then we can analyze it. Okay, okay, So now we have to find another method. Okay, now we have to find another method. Okay, so the problem is with this cos omega naught n. So this is the problem, no? This is the problem. Okay, I try to approach for this in a different way. Okay, so this is my approach. Okay, this is my approach. Okay, sometime in other textbook maybe different approach may be there. Okay, but anyway, do you have any suggestion to do this? Do you have any suggestion to do this? If you can suggest. Okay, actually I get that 30 minutes to get the idea about these questions. Okay, so I have seen that similar question already solved. Okay, so I will do this like this. Okay, first, okay, first I find the Z transform of cos omega naught n u n. Okay, so first I will try to find the compact solution for this. Okay, then if I can find the compact solution for this, definitely I will have a solution for this also. So what is this actually? Okay, so I think we no need to go through the basic approach. We can use here that scaling property, no? So here you can use the scaling property. Okay, so once I get the answer from scaling property, okay, then I can try to find the solution for n a n cos omega naught n u n. Okay, so already I have, if I am successful here, okay, already I have answer for this one. Okay, so it is multiplied by n. Okay, so maybe I will be, because when we are doing the integration or summation, sometime we will have undefined value. Okay, so I think you have come across when we are, so all the integrals are not exist. Okay, but differentiation, normally we can do a differentiation. Okay, okay, so so here n is multiplied by this function. Okay, so maybe using a differentiation property, maybe I can get answer. So I'm going to go through this way. Okay, so I'm going to go through this way. Okay, let's see whether we can go for a final solution. Okay, so I take first I take cos omega naught 10. Okay, I take cos omega naught 10. Okay, so I take cos omega naught 10. Let's say that x1 n is equal to cos omega naught 10. Okay, so we have un. Okay, uh, so um, so actually we can use that one also. We have the we have is a transform for un, that is 1 minus z. Okay, correct, and z will be greater than 1. Okay, so we will already have this identity. Okay, let's say that we will have, so this is very simple. Okay, because uh, we have several impulse like this. Okay, so this will be, if we have write the z transform, so this will be 1 by, okay, so here 1 and z z minus 1, no? Z minus 1, so this will be z minus 2, so this will be 1 by z. Okay, this will be 1 by z, no? This will be 1 by z. Okay, okay, so un will be 1 divided by 1 minus 1 by z. Okay, so I think this is okay. Okay. Okay, no? If I am doing any mistake, I think you can correct me. Okay. So here we have 1, 1, 1, 1. Okay. So here 1 is at 0, so that we have 1. Okay. So here 1 is at -1. Here 1 is at -2. So on up to infinity. So you will have 1 minus 1 by 1 by z. Okay. 1 by z. No? So you will have this. Okay. Okay. So so actually this can be also expressed as, so you can see that 1 by z, okay, when we are finding the poles and 0, okay, if we are going to find the poles and 0, it is better to have this kind of one, okay. So here 1 by z, so we can say that, so you can get the common denominator. So we have z minus 1 here, and this z goes up, okay. So here we have z divided by z minus 1. Okay, so this is the un. Okay, so here we have the numerator nz. Okay, and here we have denominator dz. Okay, then you can equal this numerator to 0 and find the z value. So here z will be 0, and this is a 4, this is a 0. Okay, and you can equal this denominator to 0, then you can find the value is at equal 1, and this will be a pole. No? Okay. So here you can, likewise you can find the poles and 0. Okay. So maybe in the exam question you may ask to find the poles and 0 also. Okay. So it is better to have the xz in this way as a rational factor. Okay, as a rational number, as a rational function. Okay. So let's say, so you can use this one or this one, no issue. Okay. So this z will be greater than 1. Okay. So I think we can use this result also. Okay. So now uh, you can see that if we can write this in an form, so here it is an. Okay. So I think you can use the same property for this one. What is the property? The scaling property. Is a scaling property. Okay, property. I forgot to check the page number. I think still we didn't see any table. No, still. Okay, yeah, this one. Okay, so you can see that. So here it is not mentioned. And so no, this one, no, this scale. So this property also we can use. Okay, if we can write that cost term in the form of this a. Okay, so do you have any suggestion to convert this cost form to this a in value? Do you have any suggestion? Please think. Actually, when you are find the Fourier transform, I think you are using that one. Okay, so it is very hard to do integration and differentiation with this cost terms. So normally we convert it to the exponential terms. So we have a power, no? So that we have a power. Okay. So to convert this exponential form, what is the method? Euler formula, no? Euler formula. Okay. So you can use Euler formula to convert this to this n type. Okay. So you know that cos omega naught n is equal to half e to the power minus plus j omega naught n plus half e to the power minus j omega naught n. Correct? Am I correct? Okay. So you can see that now this is, if you consider this is this term, it is a constant, no? Because omega naught constant, e constant. Okay, so this will be a constant. Actually, this is a complex value. This is a complex value. Okay, so complex value signal, if we are going to draw the signal, it will be a issue. It will be not a one-dimensional issue. One-dimensional signal. It will be a two-dimensional signal. Okay, so we are not going to plot the signal here. Okay, because this is a complex number. Okay, so come to plot the complex number, we should have two line, x and y axis. We know imaginary line and the real line. Okay, then if we want to represent this n, then we have to another dimension. Okay, so it will be having three dimension. Okay, so it is not a one dimensional signal. Okay, it is not, it is a two dimensional signal, no? As I can remember. Maybe I am wrong. Okay, I can't remember it, if it is a one dimensional or two dimensional. I think it is two dimensional. Okay, okay, anyway. Okay, so you can see that this is a constant. Okay, this is a constant, so it is just like a, but here a is a normally real value. Okay, but you can consider this as a. Okay, so it is a n. Okay, so now I think you can use that scaling property and you can find the value for this one, e to the power j omega naught n u n. So you can find this. What is this? Using the scaling property. Using scaling property, you can actually you can go through your basic method. Okay, then also you will get the same result. Okay, but I am using the scaling property here. Okay, so if I use the scaling property, it will come. Okay, so here scaling property said that instead of this z, we have to use az, no, z divided by a. Okay, so here we have, okay, can you remember that is the scaling property? Okay, because here you have a n. Okay, so here it should be z divided by a, so it is a minus 1 z. Okay, so instead of z, we substitute this one, a minus 1 z. Okay, okay. We substitute this one, a minus by z. Okay, so here I substitute. So this is so I'm going to substitute this one. So this is my a. Okay, so I am going to substitute a minus z. That means e to the power minus j omega naught z. Okay, so instead of z, I write e to the power j minus j omega naught z divided by e to the power minus j omega naught z minus 1. Correct? Okay. Did I do any mistake here? I think I am okay. Okay. So this is the scaling. Okay. So if I scale the uh, signal, the ROC will be, okay. So ROC will be the magnitude of A multiplied by the region of the original signal. Okay, so here my ROC will be, okay, ROC will be here Z is greater than 1. Okay, so here I will get Z is greater than, actually here it should be magnitude of 1, okay? Magnitude of e to the power, so this is say no, e to the power j omega naught by 1, okay? So what is this actually? What is the value here? What is value? So you can see that this one also 1, okay, because this is a complex value. So if you get this, if you get the magnitude, you will have cos square omega naught plus sin square omega naught root. Okay, so you know that cos omega naught t, so cos square theta plus sin square theta is 1. So square root 1 will be 1. Okay, so this value also will be 1. So no any impact to the ROC. ROC will be, Z will be greater than 1. Okay, so I think it is okay. I have explained enough. Okay, so I think you could understand this. Okay, so now I have uh, find this. Okay, then I have to find this terms also. I have to find this terms Fourier transform also. What is this term? This is very important, I think. Okay, so E minus j omega, sorry, E minus j omega naught n u n. Okay, u n. I didn't consider this half. I tell you why. Okay, I didn't consider this half. I tell you why. Okay, so this is u n. Okay, and what is the Z transform for this one? Okay, tell me, is this the time reversal signal? Is this the time reversal signal? Time reversal signal. Is this the time reversal signal? Because here e to the power j omega naught minus n, it is e to the power minus j omega naught n. Okay, so that means here we can put this as minus n, and we can put this minus here. Okay, so this will be plus. Okay, so it will be minus. So is this the time reversal signal? Actually, it is not, because this is not reverse. No, this is not reverse. Okay, so if you time reverse a signal multiplied by un, okay, the original signal will be casual signal. Okay, but the time reversal signal should be anti-casual signal like this. Okay, but here it will not be an anti-casual signal, it will be a causal signal because it is multiplied by u. Okay, so you will have the component in this range itself, not in this range. Okay, so this is not the time reverse signal. Okay, so although this is -1, here n is not -1, so this is not the time reverse signal. Okay, so I think this knowledge is very important. Okay, you will get this kind of question in your exam paper. Okay, so now actually for this one also you can go through the basic method. Okay, go through the basic method, but you can see that only different is that here we have a minus. Okay, here we have a minus. So if you get a minus 1 minus 1, you will get a. Okay, so instead of this minus, if I replace it with plus value j omega naught is at e to the power j omega naught is at -1, it will be okay. Okay, it will be okay, no any difference. Okay, so you can check this by going through by going through a through a simple approach. Okay, principal approach. Okay, but if it is a time signal, can you remember what we get? Okay, if it is a time signal, what we get? time reverse signal. So we will get, okay, we will get Z minus 1. The Z will be converted. Z will be minus. So here Z will be plus, here Z will be minus, but here Z will not be changed. No, Z is same location. Okay, it is not changed. It is not minus 1 because this is not the time reverse signal. Okay, so this Z is same as here. Okay, so that is the difference. Okay, and what is the ROC for this one? No change, no? So this one and this one look same. So if you get the magnitude of e to the power minus j omega naught, also it will be 1. So here also Z will be 1 greater than 1. Okay. Okay. Now, how can we find the cos omega naught n Z transform XZ? How can we find? Okay, so you can see that we have two function. Okay, we have two function. Let's say this is x1. Okay, let's say this is x1n, and let's say this is x2n. Okay, x2n. Okay, so we have x1n Z transform signal. Okay, okay. So here we have two signal. Okay, here we have two signal. Okay, two signal. One is let's say this one is x1n. Okay, and let's say this one is x2n. Okay, and we have the Z transform also. We have the x1n Z transform, that is x1z, this one, and x2n Z transform, we have x2z also, that is this one. Okay, so what is cos xn? So let's say this is xn. Okay, so this is yn. Okay, so what is yn? Yn is equal to half x1n plus half x2n. Okay, actually this is the linearity property. Here we can use the linearity property. Okay, so if any signal has if we got the signal, okay, by adding two signal with different way, okay, the Z transform will be the addition and with that same way. Okay, so here for Z transform signal, let's see that YZ will be half x1Z plus half x2Z. Okay, actually this is the linearity property. Linearity property. Okay, linearity property. This one. Okay, this one. Okay, so I think now we have a chance to use the linearity property also. So here I use the linearity property and I find the cos omega naught n is a transform of this cos omega naught n. Okay, so let's say that is y z, capital Y z. It is, I get half, okay, half e to the power minus j omega naught z, e to the power minus omega naught, e to the power minus j omega naught z divided by e to the power minus j omega naught z minus 1 plus half e to the power plus j omega naught z omega naught z omega naught z divided by e to the power j omega naught z minus 1. Okay. So you can simplify if you need. Okay, so this is the cos omega naught. So now, okay, Actually, you can convert these terms again into cos and sine terms. Okay, but I'm not going to do that one. If you wish, you can do this. Okay, if you wish, you can get the denominator. Okay, if you wish, you can get the common denominator, and you can try to simplify this further. Okay, I'm sure that we can simplify this up to some level. Okay, but I'm not going to do that part. Okay, that simplification part. And if you have the uh, written up to here, okay, so you will get the full mark also. Okay, we are not expecting your mathematical simplification ability. Okay, okay. So now you are engineers, and you already know this calculation. Okay, so we are not going to measure your this mathematical knowledge. Okay, because we have tools also to do this. Okay, so we are not we will not waste our time to do this. Okay, but sometime for the analytical purpose, we have to simplify it. Okay, sometime we may have to simplify it. At that time, we have to do this. Okay, for any design, sometime if we are doing any design, let's say it's a filter design. Okay, so sometime we should have to definitely we should have to simplify this up to some level. Okay, so in that case, you have to do this. Okay. Okay, so now I have find this. Okay, now my aim is to find, so this is actually Z transform of cos omega naught n un. Okay, this is the Z transform of, actually this is Z transform of cos omega naught n un, because we have considered the un. That means we have considered only plus side. Okay, so then if I get an, my next step is to find this one, this one. Okay, now my next step is to find this one, an cos omega naught n un. Okay, so I already have these terms. Okay, so what should I do? Okay, I just have to scale the time, scale the z. Okay, that means scaling means I divided or multiplied this value. Okay, that is scaling. You know that time is scaling, no? When you are doing a time scaling, it may be a time expansion or it may be a time compression. Okay, if you multiply the time by a value, let's say 2t, then it will be a compression, shrink. It will shrink the signal. Okay, and if you multiply or if you divided this t by 2, okay, that is also scaling, that will expand the signal. Okay, so that is expansion. Okay, so I think you have learned these things. You may not remember. Okay, you may not remember, but I think you have the idea. This time is scaling. We can shrink and expand the time. Okay, like we are doing in oscilloscope. Okay,